Now we're going to talk about how to solve them. Okay, the good thing is solving is so easy and you've already done it. Okay, so surface area is the total covering.
Not presenting.
Oh, I'm sorry. The total covering on the faces of a 3D object. Okay, surface area is something that you use in real life when you are, maybe when you're wrapping a Christmas present, when you're wrapping a birthday present, you're covering all the sides of that box. Okay, I'm going to cover all the sides when I wrap a gift. Okay, now if I was going to paint this room, would I paint all of the sides of this room?
Yes.
I would paint the top and the bottom?
No,
that would be crazy town. That's what we're going to talk about next. Okay, total means all of the sides. Okay, so here, when you do this, the good thing is you're really only doing 3 simple math problems. Okay, so A is going to be shape 1. Which letter do you think is the same size as shape 1? C. Yeah. So A and C go together. So if I figure out A, I don't have to redo the math again. Okay, I can just write the same number. B is going to be shape 2. What else do you think matches shape 2? D, as in dog, or duh. And then obviously E and F will match each other. Okay, so you're going to find the area of each little part, then we're going to add them all together. Okay. Yeah. All right. So total surface area. Sometimes you see it as TSA, total surface area. Okay. You're going to add all the sides or the shapes. Okay, you're adding everything up. If I wanted to know how much fabric I needed to maybe make a covering for some box, or if I'm a Kleenex company and I want to know how many Kleenex I want to fit in there, okay, I got to know how big to make the box so that it covers it. Okay, so you add all the sides. It is the covering. Again, this is talking about the outside, just like area. The covering of all the faces, including the bases. Okay, so it's the top, it's the bottom, it's the left, it's the right, it's the front, it's the back. This is a lovely gift from Brandon Crane, 7th grade, 2015. This is a 5-year-old diamond you're looking at.
5-year-old?
Yeah, it's just a little paperweight that one of my students gave me.
How did he get that? It's gotta be worth for you.
Okay, so I'm going to show you how easy this is. Okay, I don't expect you to draw this out and do all this. Okay, but we're doing it just to show you how to set it up. Okay, so first thing you want to do is shape 1. Let's say this is shape 1. Okay, what shape is that? Rectangle. And how do you find the area of a rectangle?
Base times height.
Base times height. Okay, so if I look at this rectangle, the base right here is what?
8 meters.
8. Remember, this is 8, this is 8, this is 8. So it's 8. What is the height?
15 meters.
15. And I'm going to save you all time and tell you the multiplication so that we can get through these notes. It's 15 times 8 is 120. Okay? So this guy is 120. Is there another one that's also 120?
Yes.
Yeah, the third one is also 120. Okay? So I want you to be in the habit of writing the answer inside the rectangle. Okay? And remember, you always skip a space. So, like, obviously, these are not going to be the same. So these two would be the same. Okay? Shape 2 is a what?
Is a rectangle.
Rectangle. BH. Easy, easy formulas. Okay? For shape 2, my base
Is 6 centimeters.
is 6. My height is, what's my height?
15.
15. Okay. Now this is the part where people get a little confused because they don't understand how that could be the same. But remember, just like you saw in that little simulation, when I fold these up, they are the same size, whether they look like it or not. When it's connected like this, you just have to think of it folding up and making the same size. So like on this guy, it folds up. Okay, so if this is 11, this is 11. If this is 3, this is 3. So these are the same. You just have to memorize that. Okay. And our last shape is this guy. He is a rectangle, which is BH. What numbers make up this rectangle?
8 and 6.
Yep, base is 8. Height is 6, which is 48. I forgot to write my numbers last time. Okay, so that's 48. This is 48. I forgot to write the green one, says 90. So this is doing what we've already been doing, composite shapes. You're just doing a bunch of little areas, and then what do you think we're going to do? Then add them. Okay, does everybody understand where the numbers came from inside here?
Yep.
Okay, now we just add them. You have a calculator, go ahead and add them. Actually, I'm going to save you time, and I'm going to tell you the answer is 516, because I want to make sure we have time to finish the pear deck.
So, put that on to the
Yep, so that's the total surface area. Don't forget those units.
Should we
Okay.
put it this way?
So all we did, right here, so I did 48, 48, 120, 120, 90, 90, and I added them. That's how I got that. Okay. Pretty easy, right?
So,
Find the area of each one and then add them. It's just like what we've already done. Okay.
nice.
Let's look at on the next page. So this is total. You add all the sides. Last thing we have to talk about is lateral. Okay, it's LSA. Lateral surface area. LSA. Lateral is the is the sum of the areas. Sum means to do what?
Fence.
Add, thank you. Okay, it's the sum of everything except the bases. Okay, LSA is the opposite of Meghan Trainor. Meghan Trainor is all about that base. LSA says, no thank you. I am not. Is that too old of a song for y'all to reference? Do y'all know that song?
I don't remember Megan Trainor
Okay.
anymore because she
She's saying, you know, I'm all about that base.
Yeah,
Okay, but LSA says, I am not about that base. I'm not Meghan Trainor. I want no bases. Okay, I don't want no bases. LSA, no bases. Lateral means no bases. Lateral means the sides only. Okay, that's like painting this room. I would not paint the ceiling. I would not paint the floor. If I was making a soup can, I would not put a label on the bottom or on the top. Okay, lateral surface area.
No one would see it.
Mm-hmm. All right. We're going to do this one right here. So our bases are going to be these two guys because these are my flaps. So do I even need to find the area of the bases?
Yes? No.
No, because I don't care about no base. Okay, I don't care. I'm sorry, Colton. I don't know if you hate my singing or that song, but I'll try not to sing it again. Okay, so this one, it's a rectangle. What's the formula? How'd you get that, though?
I did 5 centimeters plus 5 centimeters plus 4.2 plus 4.2.
Okay,
That works too.
so every time you do this, I'm not making you write the formula, but I want you to write the numbers that you're multiplying in there. Okay? When you multiply that, what do you get?
Oh, yeah, that's a bigger number.
21. Okay? Now, is there another one that's also 21?
Yes.
Yeah. Remember skip, and this one's 21. And if you're not sure why, it's because when I fold these over, remember, this guy and this guy are parallel, means they never touch. So these guys are parallel, just like these guys, parallel. So there always has to be one in between. All right, this next shape, it's a rectangle. The base and the height. I don't have enough numbers, so I'm going to come over here. The base is what? 2.9. What's the height?
5 centimeters.
Everybody, what's the height?
5
5 centimeters. 2.9 times 5 is 14.5. And again, I don't have to do the math again because I already did it here once. 14.5. So now what do you think I do? Add everything but
The base.
no base. So we're going to add 21, 21, 14.5, 14.5.
50. Or what? How did I get 50? I did 21 plus 14.5 times 2.
Did you add 21 twice?
No, so I did 21 plus 14.5 times 2.
You only multiplied 14.5 times 2. You have to put it in parentheses otherwise. Like if you're going to put it in a calculator, you have to put it in parentheses before you multiply because of order of operations. Okay. Everybody okay with how to do this? Okay.
Yep.
Lateral, no basis. Total, yes basis. Okay. We're going to do one more. Now, the good thing is in 7th grade, you only do nets. So, like, you don't have to try to figure this out because this is where it gets weird. We're going to do this for volume. So, I want you to turn back one page. And we're going to do the total surface area for this one right here. We'll pick an easy one. Okay? Total, sorry, we're going to do lateral. Let's do both. Let's do lateral first. LSA, lateral surface area. Okay? So we're just looking at this one, and this is the last we're doing, I promise. Okay? This rectangle, I multiply 15 times what?
5.
And I get 75. Okay? This one, what is the base?
That would be
The triangles.
15. What's the height?
85.
Oh, I already know that one. 75. What's this one?
75.
15 times 5, which is 75. So my lateral surface area is 75 times 3, or 75 plus 75 plus 75.
225. Yeah.
225 what?
Feet.
Feet what?
Feet squared.
Feet squared. Okay? So that is if I only want lateral. Okay? Instead of doing a whole nother one to do total, let's just finish this one and let's figure out the total. Okay? So now I need to add in those bases. What shape are those bases? What are they? Triangles. What's the triangle formula?
1A equals 1/2 of B over C.
BH. Okay? So 1/2. The base is
5.
5. The height is,
I think that's 6.
yep. So half of 6 is
3.
3 times 5 is
15.
15. So this is 15 and this is 15. So total surface area
30.
means I have 75 plus 75 plus 75 plus 15 plus 15, which is 225, which is 255. Is that right?
240.
Ah,
It would be 245.
I mean, 245.
245? Okay. I thought you said add 30.
No, no, it'd be 255.
Hold on. Wait, so add. So
Sorry,
32,
yeah, it'd be
25
255.
plus 30.
Oh, yeah, sure.
255.
It's 255.
Yes,
Okay.
255. That's
I was going to say, I think I'm losing my mind. Okay?
My brain's not working that well today.
So the only difference is when I have total, I add them all. When I have lateral, I have to ignore the bases. Okay? And that is it. Okay? Pretty simple, nothing too crazy. Everybody feeling okay with that? Yeah? Okay. Go back to the